Today I'm going to present a seminar on interactive evolutionary computing by EEG analysis. This topic combines evolutionary algorithms with human brain signals and also to create smarter and more adaptive systems like this. Interactive evolutionary computing, when or also referred as the IEC, is a method where human feedback is used to guide computer algorithms. Uh, and also which it stands for the electro electromagnetic and captures brain activity non-invasively. By combining brain activity non-invasively, it can analyze IEC and EEG analysis. We can also build systems that respond directly to the user's mental state, making interaction more natural and initiative. Okay. By this, the overview of the evolutionary algorithms begin with the evolutionary algorithms are inspired by the natural selections. They work by generating populations of solutions and improving them using selection, crossover, and mutation. Traditionally, these algorithms are rely on the mathematical fitness functions, but human feedback can also be used as the guide to for the evaluation. And when it comes to the what is interactive evolutionary computing, it is an interactive evolutionary computing. Humans takes part in the evaluation stage. Instead of the system deciding what solution is best, users select solution based on the preference. This is especially for useful for the problems where quality is subjective, such as design, music, and also art. And the role of the EEG in human computer interaction. EEG measures electrical activity in the brain using electrodes that placed on the scalp. It helps to detect mental states such as attention, engagement, and stress or relaxation. Using EEG, we can also understand user reactions without requiring explicit input. Uh, and also, EEG signal acquisition and processing. EEG signals are acquired using multiple electrodes, and it can have signal processing involving filtering, artifact, and also it has a feature extraction. By this feature extraction, we can extract the frequency bands and event related potential that can be analyzed to infer mental states of a user. The common EEG features for the user state detection is different EEG frequency bands represent different mental states. For example, alpha waves relates to the relaxation, beta waves relates to the focus. When it comes to the theta waves, it relates to the drowsiness. Event related potentials are frontal, and it can be also used to understand the emotional responses and the cognitive responses of the user. Integrating EEG data into the IEC framework. In the EEG-based IEC, the extracted EEG features are used as a feedback instead of manual user ratings. Machine learning models classify these brain signals into the estimate user preference, and this information guides the evolutionary algorithm. The EEG derived with the features that are used as an input to evaluate solutions or guide the selection process. By this classification, the influence of the evolutionary operations in the algorithm is begins. System architecture for EEG driven IEC. The system includes EEG acquisition, hardware, signal processing. It has various modules and evolutionary engine. It can give real-time feedback mechanisms, update the pollution, like population based on the EEG analysis. Through this, the user interface displays candidate solution for evaluation and selection. It can be various forms. In the Cortex handler, it has task mode and test mode, and in the socket IO, it can have event handler. In the Flask, it should have the routing functions and influx DB. In the influx DB, it has neuropsychological tasks like data analysis, data import, data export, and it sends to the CEP. Later, influx DB sends the operations into the exported files. Applications of EEG based IEC. Personalized content and game adaptation based on user engagement. Assistive technologies to help users with communication or control impairments. It can optimize the design of artistic processes driven by the subconscious preferences. This approach is very useful in personalized gaming, in creative design. It also helps to adapt automatically by the user engagement and preferences. When it's come to the challenges of the EEG, it has EEG signals are prone to noise and artifacts affecting accuracy. In the real-time processing, it requires efficient algorithms and hardware, and also it interrupts the complex brain signals into the meaningful feedback remains a research challenge. So, real-time processing is computationally demanding and accurately interpreting brain signals. Advances in EEG analysis. In the recent advancement like deep learning and transfer learning, it has improved EEG signal classification by combining with the biosignal, further increasing accuracy and reliability. It has done various case studies. It has four steps like acquisition, denoising, featuring, and classification of the dataset. Users evaluate when it comes to the case study, EEG guided art design optimization. In this case, EEG signals are used to detect the subconscious preferences while users view artworks. The system evolves art designs based on emotional responses, improving satisfaction and creativity. By this, by the end of the case study, we can get the results showed increased satisfaction and engagement in the creative process by the user. When it comes to the second case study, the game personalization. Here, EEG monitors player mental states to adjust game difficulty and content dynamically. This creates more immersive and enjoyable game experience. Ethical considerations. EEG data is highly sensitive, so privacy and also transparency are critical. Users must know about their brain data is collected and stored and used. It has many limitations like highly equipment cost, signal variability between users, and difficulty in interpreting brain data and key limitations. Further, system must more adaptable and user friendly. Conclusion. In the integration of EEG analysis into the IEC represent a promising frontier in adaptive system, and also it has compromising field that enables adaptive user-centered system with advances in machine learning and signal processing. This technology has strong potential for future applications.